All right, so we've seen a little how to calculate some heat values, change in enthalpy. You can see very easily if you're given a certain amount of grams of something in an equation, you can change that to moles and then know that if you're given the formula with that change in enthalpy, you can determine how much was released. What our next little, I guess, calculation is when you don't have the delta H. So notice I have a sample of sodium chloride dissolved in, and so basically let me think about this. We've got 100 grams of water. Okay, this is my water right here. And I'm going to put NaCl into that water. Okay. Now we can call this a calorimeter. Notice it's dropping from 27 to 20 to 22. So it's going in that negative 5 degrees Celsius direction. Oops, let me just rewrite that here. Change in temperature is negative 5 degrees Celsius. So this is an endothermic reaction. Endothermic because it's getting colder. But basically I'm asking to calculate the delta H, and I have the amount of grams of this stuff, but I don't know what the delta H to use with that yet. So, you know, this 17.7 might be 1 mole, it might not be, whatever, but we got to have that delta H. So here's an equation of what's going on. We've got the salt being dissolved, salt being dissolved in water. Now, since it's being dissolved in water, really what's happening is the solid is just breaking down into the two ions, the Na and the Cl in the water. So we have salt water. Oftentimes, you know, if we're doing a lab, I'd write this NaCl with the AQ sign. That just means, of course, that it's salt water. Salt's been dissolved in water. So that's kind of what we've got. Now, here's my equation. Now, it'd be great if I could just take that 17.7 grams of salt, figure out how many moles, and then use the delta H that's given, but it's not given yet. So what we're going to do here is basically use the two kind of steps that we've seen already. The Q value, which is the mass times the change in temperature times the specific heat. And since this is water, this 100 grams of water, we're going to use the Q for water. Okay? That's going to give us the delta H for this equation right here. And once we have that equation and its delta H, then we can worry about the moles of the 17.7 grams. All right? So the Q is going to be 100 grams. Again, I'm doing this for water. The change in temperature is negative 5 degrees Celsius. The specific heat is 4.18 joules per gram degrees Celsius. Whoops. Joules per gram degrees Celsius. Do all the math on that, and I get Q is equal to negative 2090. All right, so that's the joules. Notice my grams cancels, my Celsius cancel, and I get joules. All right, so that's the Q of the water, right? Which means that the Q of the NaCl is going to be positive 2090. Remember, the Q is equal to the Q, just the surroundings and the reaction. So the water absorbed, the salt must have given 2090. All right? So that means, notice my coefficient in front of my NaCl is 1. If we have 1 mole of NaCl, we'd have 2090 joules. But we don't know if we have that. Let's figure it out. Grams, moles, 1, 58.5. And that's going to be, when I divide that, 0.303 moles. Again, let me grab a different color. Let's go back to that white, I guess. All right, so I've got my moles. X line, moles. In this case, it's just joules. Here I am back at the top. It was in kilojoules last time, but it's still just an energy. 1 mole, Y1. My coefficient up here is 1. And then my 2090. Multiply my 0.303 by 2090, and I get 632.4 joules. And there would be the amount of delta H for this amount of NaCl. All right?